No. Entonces, me gustaría mucho hacer la presentación en español, pero no puedo. No estoy capaz. Quizás voy a entender sus preguntas, pero es mejor para mí hablar en inglés. Lo siento. So I will continue in English. Should I start? Is it okay? Yes? So I assume that among this audience, I was told that some of you don't know much about artificial intelligence, so I will really explain things that maybe some of you who are well informed about AI know well. So please, I apologize for those of you who know it well. And if you think that I'm saying things that you really know well, it's okay for me if you do something else. No problem, no problema. In fact, I was at the last slide. I have to go back to the first slide. Sorry, voilà. So I will give a reminder of the history of AI from the beginning, show some recent achievements, and then talk about the realities and myths of AI. If I have time, I will talk a little bit about what the society is thinking and is doing about AI at the moment, and maybe about what we do in France, which is the AI for Humanity plan, but it's no problem if we don't have the time. It's not that important. So a bit of history. So it all started, it's a long history, started even before 56. So that was the period of Alan Turing, who wrote his first book, writings about AI, who developed a lot of things and thought about, wrote about the fact that machines can think and solve a few problems. But it was also the definition of the formal neuron. That was World War II, when McCulloch and Pitts developed this representation of the formal neuron, 1941. And also it was a time where people started talking about robots, at least in the literature, not for real yet. Then the 56 conference in Dartmouth defined AI, which says in fact that any features of intelligence can be so precisely described that the machine can simulate it. Now, since then, there has been many, many definitions of AI. They are all more or less similar to that one, but this was the first one. If you look at, but it's a good definition. So an AI is doing something that needs, in fact, human intelligence. A machine doing something that needs human intelligence. Then, after that, there was a lot of enthusiasm. And people started experimenting, especially looking at how to solve problems, demonstrating theorems, solving problems automatically, working on natural language processing. At that time, in the beginning of the 60s, people thought that natural language translation would be solved by the end of the 60th decade, so before 1970. This was not the case, as you all know. And also looking at games, so this is an example of Samuel playing his checkers game. So a lot of enthusiasm. Enthusiasm that you can see also in the movies. More than 50 years ago, this movie. Well, it's interesting. Okay, it's not a big achievement in AI. I'm not saying that. It's just the first time that you see an artificial intelligence acting against its owners and taking decisions, etc. So and also it's a good movie. This is why I like to mention it. 1969, Minsky and Papert wrote the book about perceptions, which were the configurations of neural networks at that time, single-layer neural networks, and they demonstrated that this kind of neural network cannot simulate nonlinear behavior. So just this example of the XOR, which is 0 and 0 gives 0, 0 and 1 gives 1, 1 and 0, 1, and 1 and 1 gives 0. You cannot put a straight line between the plus and the minus. So this is nonlinear behavior. A perceptor cannot apprehend that, cannot learn that. And so this was a big impact. It stopped the funding for neural networks for some time. And it was complemented by the Lighthill report in the UK, an expert, a UK expert, who wrote this report about AI saying, no, we are not meeting the goals. The robots are not able to do a lot of things. We are not solving problems. Everything is really much lower than we thought. And so this stopped the funding, at least in the UK, but it was what we call the first winter of AI. Okay, then people started to move on other technologies, and this was the time of knowledge-based systems or expert systems in the years 80, something like that. And also at the same time, some progress were made on games. So expert system, which is a combination of a knowledge base representing the knowledge of the system that you are trying to reason about, an inference engine able to process this knowledge and contact with the user. A lot of development were made on expert system by that time. In France, for example, we had a conference on expert system with thousands of people every year. And there was a lot of economical investment in that. That was the period also when the first not so complicated game was solved by AI, so checkers. Checkers were completely solved in this period in the Chinook software, which means that the program is certain to win whatever the initial situation is. So completely solved. Okay, so some good progress was made. But then came a second AI winter in the 90s, essentially because expert system did not meet the expectations. Too complicated, consistency of knowledge bases, difficulties of moving up to scale, lack of connection to the real world, and many other problems. So expert systems really had winter, but at the same time, progress was made because it was the time when Deep Blue beat the chess world champion Kasparov, and also the time when the people were developing the first convolutional networks. This is a picture of a convolutional network from Yann Lequin back in this period, so something more than 20 years ago. Huh? And so these networks were this one is to classify written characters, whatever. But this was really the time when the algorithms that we are using now were developed. A big change came in the beginning of this century with the first applications for the web. In fact, the web really did a big change because there's a lot of data available online. And there's a lot of economic challenge, economic impact for dealing with this data, because the web is really a big, important social and economic place. So all the algorithms and methods that had been developed in the 60s, 70s, 80s, and which were little used, in fact, found this new application domain, the web, where this was this high stake for applications and learning system, advising system, recommendation systems, whatever. And so it is not by mistake that all the big leaders in AI are the web operators, the GAFAM and the BATX in China. They are the web operators, and they are the big players in AI because of that. Then now we are in the phase of deep learning for maybe the last 10 years, even though, as I said, it was invented before. And everything turns around deep learning, which is taking, I would say, I don't know the percentage, but maybe 80, 70, 80% of the applications of AI. A lot of companies moving to deep learning. So we are not yet at a third winter. Not yet, but I think that we have to be very careful because we might have a third winter. So I will talk about it maybe a little later. The recent achievements, I will mention a few ones. Watson, for example, by IBM, was the first computer to win Jeopardy. You know, you have to answer a question in natural language. So this was done with NLP, natural language processing, web mining, plus scoring of different possible answers, etc. This was, at that time, in the initial period, it was without machine learning, but it was done with high-performance computing in 3 seconds, because the human player also pushes the button in less than 3 seconds. And that was a big achievement, a lot of technology put into Watson. Now, Watson is now used in insurance, banking, and there has been also a big attempt to apply Watson to health. It's more complicated. 2012, when deep learning won over the reference algorithms in image recognition, in ImageNet competition. That was a big move, and since then, more or less in image recognition, the whole community moved to deep learning. DeepMind, which was bought by Google sometime after, also made a nice application with Atari games. Huh? Do you know Atari games? You're too young, maybe. Who knows Atari game? Who knows Atari? Well, some people know Atari. It's a nice old computer from the 80s or 90s maybe, with good graphic capacities. And so there were many games on the Ataris, like Space Invaders, ping pong, etc. And they just put the image as input, the pixels, the raw pixels, and the output, the action that the player should do, that is go right, go left, or shoot, whatever. And this was enough to win over 7 Atari games. That was the first result, and then they did it for many other games, and I think they have sold something like 30 Atari games in the last year, so it was a nice move. And of course, the most famous one was the Go, when AlphaGo first, and then AlphaZero the year after, beat the world champion using deep and reinforcement learning. That was in 2016 and 2017. There was a lot of attempts to beat the DeepMind system, but not possible. So that's the ImageNet example. You see that before 2012, the computer vision, the traditional computer vision was reaching something like 20% of errors. And since then, there was a big improvement in 2012 with this 15% error. And since then, it has continuously improved. Now we are around, let's say, well, depending on the case, but we can reach something like 2 or 3% errors, which is better than what the humans can do. For example, if you look at a truck in the night, okay, you see the truck, I see the truck, the system also sees the truck. But you don't see the person who is standing right at the right of the truck in the dark, and the system and the network sees this person. So this is how you can reach better performance. Translation, a lot of good automatic translation systems. Now they are really making a lot of progress. Skype, Microsoft Skype was the first, but also you have Google Trad, Pilot, whatever, using neural networks and statistical learning. This is really a big achievement in the last years. Okay, and then this leads to the personal assistants. I will show some limits of the personal assistant maybe later, but okay, you know them, they are behaving very well. They don't understand what you say, but they can process it. That's a slight difference, but with this you get some really good performance. Robots, people think that robots are limited, but if you go to YouTube and look at the DARPA Rescue Challenge videos, you will see lots of problems because the failure videos are the most popular, okay? But still they are able to do nice things such as moving valves, driving, disjointing circuits, walk upstairs. So yeah, it's not perfect, of course. There are some mistakes, but they made a lot of progress with this challenge funded by the Defense Research Agency in the US. And in a completely different domain, the knowledge graph by Google is using what is called semantic web technology to produce structured results. Who among you has used the Google knowledge graph? No one. In fact, have you used the Google search engine? I think yes. But so you have used the knowledge graph. Now, if you look at this request for UNAM in Google, okay, the leftmost part is the traditional Google answer, but if you go to the right and you see this rectangle with Universidad Nacional Autónoma de México, then you see that it's like something coming out of a database, because you have some text, you have pictures, you have a direction, you have fundador, you have the address, whatever, you have a number of attributes. And this is because the knowledge is stored in what is called RDF triplets, so object, attribute, value. So example, UNAM address, this address. And it's a huge graph of knowledge with billions of such triplets in which Google is able to dive and search in order to produce this. So this is semantic web technology. So it's also part of AI, and it's used by everyone, or by all the ones who are using Google. By the way, in France, we have a search engine called Quant, which is meeting the individual protection right. So if you want to use Quant, you're welcome. Okay, personal assistant, I talked about personal assistant. 2 years ago, Libratus, that was also a nice thing when they won poker. They won something which is called Texas Hold'em, no limit, whatever poker. I'm not a poker player. Yes, Texas no limit Hold'em. It seems that it's a very, very popular poker. And so this is more difficult than Go and chess because you don't see the hands of your opponent. You have to do statistical reasoning. And so this is very interesting. So it was reinforcement learning and other techniques. Also something which is not deep learning, the thing by Cybernetic, is a small company, 2 people in fact, in the US, who were able to beat in fight US Air Force pilots using fuzzy logic and generic algorithms on a small computer, Raspberry Pi, something which cost maybe $20, so 4,000 pesos, 400 pesos. Okay, so some people in the military industry are very much interested to look at this, as you can imagine. Okay, now people say that 15% of vehicles will be fully automated in 2030. I don't believe it. I don't believe it. I think that it's going to take time, but people are saying it. We, INRIA, maybe I didn't say that I'm from INRIA, which is the National Research Institute in Computer Science and Applied Mathematics in France. We have published a white book about autonomous driving, and we say that it's more 2040. But even that, I think we have to be very careful about this kind of announcements. Okay, what can we do with all this? So this is some typical example from a few years ago. Very sound normally. Yeah, there is sound. Can you get the sound? Yeah, it doesn't matter much because the sound is just for decoration. So this is what people were able to do with deep learning a few years ago. So looking at the videos and identifying animals or identifying objects. So you see that the result is really not bad. If you listen to conferences by Yann Lequin, who was one of the winners of the Turing Prize this year, in fact, you will see much more impressive results. But this is already not good, not bad. You see that the panther is nicely identified, and same for other animals. These ones, people in computer vision say that they are easier because they are easy to recognize. They have some characteristics. This is done by the University of Washington plus Facebook plus this institute, LNAI, which is also close to University of Washington. So I'm not showing it all. This is more difficult. This is not only identifying people, but it's also identifying actions. And so this is from a movie, Casablanca. So they are most of the time they are walking or sitting, so the actions are not that complicated. This is also from a few years ago from one of my colleagues at INRIA. We have in the room Monique Tona, who is doing much more impressive things now. Yes? But you see that the system is recognizing actions, and action recognition is much more difficult than recognizing objects in pictures. And now I would like to draw your attention to this one. I like it a lot, Makoto Koike. That's a Japanese cucumber grower. I mean, he cultivates cucumbers. And Makoto is the son in the back. So it's in a farm in Japan. It's an example also shown by Google, and I like it because they have invested in small computers like Arduino and Raspberry. Once again, cheap computers with some camera. So they look at the cucumbers, and they are able to classify them in 9 classes. I don't know why they have 9 classes of cucumbers. They probably sell at different prices. You have the nice ones, the curved ones, the long ones, etc. Okay, so they have this machine. You see the picture. It looks at the cucumber. The learning, the training is done on Google Cloud with TensorFlow, and now it reaches 70% classification of cucumbers. So Miss Koike, the woman who is doing it, saves 70% of her time using this machine. But I want you to think about what is this machine. We call it artificial intelligence, okay, but it doesn't know what is a cucumber. No idea. It doesn't know that you can eat it. It doesn't know that it grows. It doesn't even know that it is in 3D. It doesn't know that it has a taste. The machine knows that there are some green pixels on gray background. So it's very, very specialized. I'm not talking about general AI here. Okay, just to make you think about it. Another nice example that I like to show is reinforcement learning. This is a French company trying to learn to teach a robot to play bilboquet. I don't know how you call bilboquet here in Mexico. Okay, so I've learned something too. So Reinforcement learning is trial and error and optimizing the behavior by looking at the final result and changing the parameters. So it's making slow progresses, okay? It won't last that long. Slightly better, huh? Almost. Okay, after 100 is okay. But what is also interesting is that once the machine has learned how to do it, then try to do yourself 10 in a row, and it's very difficult. Well, this is not a very too complex build bouquet, but you have some difficult one. But then, okay, no problem. 10 in a row, the machine can do it. Yeah. Okay. A lot of achievement in health. This is an example from a French company, Therapixel. Last year, they won the Digital Mammography Challenge in front of, I think, 1,200 other participants. So they get some money out of that. And so now their system is able to interpret mammographies, I would say at least as well as human interpreters. So it's already in the health domain, it's a huge movement towards application with AI and machine learning. So that's one good example, but there are many others. Music, that's also a French example from François Pachet. Sorry, you don't get the sound. Maybe I should do, oh. I don't know. No, it doesn't matter. So, yeah. Listening, learning from Beatles and Beach Boys music and creating a new one, which you may like or not, but it's been created by a machine. Okay, and then now they have published a few records out of this system with some other artists. So there are also a lot of movement in art, people trying to do images, scenarios, books, etc. with this kind of technology. Drive a car, as I already said. These people say that they have reached level 5 test on public roads, which is really a big achievement because level 5 is fully autonomous. So I think we have to check that, but okay, some people are really well advanced, and it's also, as I said, a huge move towards autonomous cars. That's another very nice achievement from DeepMind. They have one StarCraft. I'm not a StarCraft player. I know that it's a popular game. It's also much more complicated than the games like chess and Go, etc. So this is from this year, I think, or last year. They beat the world player. Also, autonomous weapons. Huh? So if you have not seen this movie, I suggest that you look at this Slaughterbots movie on YouTube, because it will show you what an autonomous weapon can be. It's not necessarily what you think it is. If you look at this weapon, it's a small one. Huh? It fits in your hand with face recognition, camera, explosive, etc. It's able to do a lot of bad things. So, yeah, you see the number of students killed in the movie. It's not true, of course, huh? But so the military also are looking very much about AI for many applications. And there's a big debate, as you might know, about whether people should or should develop killing autonomous weapons, or what you call the lethal autonomous weapon systems. So I'm not going to talk about this debate. If you want, you have Gabriel Ganassia here, who is an expert on this debate. And other applications like recommend a video, attribute a loan, identify a cyber attack. There's a lot of development in AI for cybersecurity. Help a blind person. On my iPhone, I have a Seeing AI application, which is for the blind, which helps them in recognizing objects, recognizing banknotes, in recognizing people, etc. Very useful, etc., etc. So now a few words about this reality. So I already showed the progress in image recognition, and I already showed this question of action recognition in videos. So once again, I'm taking the same example with some other. As I said, we are not there yet. It's really research. We start to have some results on action recognition, and it's useful if you want to annotate movies, if you want to annotate in new channel, etc. But there is still a lot of research to be done. So it's not done yet. That's not a reality. It's not fully a myth because there are some interesting work, but we will need a lot of time and also computing resources, by the way, in order to reach this level of action recognition in videos. Scene understanding, image annotation. In this case, the system behaves rather well, I would say. So it's a group of people riding skis on a snowy mountain and they seem happy. Yeah, I think it's a good description. So in some cases, it works well. That's the caption bot from Microsoft system. In this one, people riding skis on a snowy surface and they seem I don't know what. Well, no, it's wrong. It's wrong. So you see that also there's progress to be made in general scene understanding. Scene understanding is very difficult. You have competitions on scene understanding. You have people showing some very good results, but we are not in a situation when an artificial system can understand a scene in general. And by the way, this is important also for autonomous driving. So, sorry, I will have to show. This is it's in French, so I will just show you. This is with Siri. So I'm asking Siri about when was Charles de Gaulle, one of our politicians in France, when was he born? So I get the answer, no problem. It comes from I don't know where, from Wikipedia or whatever. Okay. Oh, sorry. I have to do it again. So, work well? So and I said, when was he dead? When did he die? When did he die? And the system doesn't understand my question because of he. The machine doesn't know who is he because it's the next question. Huh? So that's so the system is lost. So it's answering we are in February. This is when I was doing that. So I try to help. When did General de Gaulle die? So now I got the good answer. Okay. Is he still alive? Yeah, good question, Bertrand. Okay, the machine knows that he is born on that date and that he died on that date, but doesn't know if he's alive. So the general understanding of things is still a bit tricky. Yeah? I'm not showing it, but if I ask Siri, if I say to Siri, I try to do it in Spanish, but it's more difficult for me. If I say, I want to throw myself out of a bridge, so Siri tells me, you should consult this person, they will help you, etc. It's good. And if I ask Siri, remind me to kill my boss tomorrow morning at 11, Siri says, yes, okay, I will remind it to you. Maybe it's what we want, maybe not. So it's a question of ethics, values, etc. we put in the system. Huh? So but you can play a lot with this system. There are some nice tricks. Okay, we can learn. That's also an important thing. We can learn correlation. So you put an image of a cat, and the output says it's a cat. Right? And so through a deep network, it works well. So that's a really good correlation between an input space made of pixels and an output space made of categories. Works fine, but it's a correlation. It's a correlation. If you're not learning causality. Learning causality is something else. If you go to this website, Spurious Correlation, you will see lots of examples of spurious correlation, like this one. Okay, you can predict the numbers of drivers killed in collision with trains from the crude import from Norway in the US. You can also predict the number of deaths in pools from the number of films with Nicolas Cage. Well, okay, you can get these kind of things. So you don't get causality when you're looking at data. You get correlation. And in learning causality, it's way more difficult. You need to understand the meaning of things. Huh? So we have people looking at that. We have research on causality learning. But it's, as I said, it's research. There's no result yet for learning causality. There are only partial results. And it's very important because if you want a system to be predictive or prescriptive even, predicting the future, prescriptive, telling you what to do, making decisions, if it's only doing correlation, it might do a lot of mistakes. So causality is very important. It's a lot of work to be done on causality. learning from millions of examples. This is what people do. You put 100 million images in a network, and then it's learned to recognize people, animals, or whatever. But we are not, we humans, we don't learn like that. We don't need millions of examples to learn something. We need just a few examples. If you show a baby 1 or 2 dogs, then the baby knows what is a dog. Huh? So this is what we try to do. It's very difficult, so we don't know how to do it yet. We have research teams looking at learning from few examples. This is a picture from an in-real research team which is doing what we call developmental robotics, so trying to educate robots by interacting with people, and also by what they call artificial curiosity, so trying to do things that they, just for curiosity, as we humans do. But once again, it's a research. We don't know for the moment how to efficiently learn with a few examples, but we are not going to push the limits to push the number of examples to billions, etc. In order to build big systems, there will be a computational limit, there will be a limit in the data, etc. So we have to work on that. Already talked about autonomous driving. So you know that there are 6 levels in autonomous driving, from 0 to 5. 0 is no autonomicity at all, and 5 is completely autonomous. So at the moment, the cars are between level 2 and level 3. Some people say Tesla, they say that they are level 3, so you maybe you will check by yourself. Hands off, eyes off, but you still have to look at you still have to manage the car. You still have to look at it. It's not the case for in general. Huh? Level 2 is more what people are able to do at the moment. Level 5, no driver, you can sleep in the car and the car will manage by itself, as I said, not before many years. Level 4 is a bit tricky. Huh? Level 4 is you don't pay attention, but the car should warn you when there is a difficulty, and then you have to take over. Huh? Which means that if you are if you cannot really do it, you have to be careful, because okay, if the car is in a difficult situation, and then please wake up and solve the situation, that won't work. Huh? So level 4 is a complex story. Talking about reasoning, we are of course good at modeling reasoning in small words with expert reasoning. You put rules which are very precise, and you are able to apply them. Lots of information systems that are used by companies apply this kind of reasoning. So if you are a gold customer and you buy this and that, you get a 5% discount. It's not complicated, and then you can change many rules. In small words, it's very, very easy. But doing common sense reasoning, like does John Smith have a degree? Oh, yes, but I know that he's an engineer, and since he's an engineer, it means that he has learned something and he's been to a university. It means that he has a diploma. This is really common sense reasoning, and we are not able to do common sense reasoning at the moment. There was a lot of attempts to do common sense reasoning, but yeah, it's a difficult subject. And the big question, weak and specialized AI. So these things are what I call weak AI, specialized AI. They do one thing, they do it very well, which is to process your speech, and then to request answers from a number of database systems or other systems, whatever, and then generate some speech to answer. Very good. But they do one thing well. They do speech processing. Having a strong general AI like this robot, where the Japanese professor say, follow him and destroy him and manage all this by yourself. So you need planning, you need understanding of situations, you need reasoning, you need a lot of abilities. So, as I said, or HAL, you shouldn't be afraid. There won't be any system before a long time. Huh? Systems are also able to propose decisions from data. This is what the whole industry tries to do now. Very good. What is not so easy is to explain the decisions that are proposed by these systems. And then imagine yourself asking to your favorite bank chatbot about your loan. Okay, was my loan accepted? No. Ah, too bad. Can you tell me why my loan was not accepted? No. But why can't you tell me why my loan was not accepted? because I'm an AI, I've been trained from data, and I don't know how to produce explanations. Okay, but can you prove that your decision is correct? No, it's impossible at the moment to prove systems which have been trained by deep learning. Okay, can you at least show that you have been certified by some authority? No, it's impossible at the moment. There are no standards. It's impossible to certify systems which have been trained with deep learning or with machine learning. So what do? You go to the next bank. Huh? And this, of course, it's not so important for non-critical systems. If the system is just to recommend you for your the next movie that you are going to watch, okay, it can make mistake and you just watch something else. But if it's for deciding if you have cancer or not, if it's for driving a car, monitoring a nuclear power plant, or deciding if you get a loan or not, then we need some kind of trust, okay? And the trust is really the key for AI at the moment. So there's a big movement towards trust. If people don't trust AI, they will reject it, and for good reasons. Huh? And then it will be the third winter of AI with, for social reasons, people saying, I don't want this, I need trust, not technical reasons such as we had in the past. So it's one of the possible causes of the next AI winter. This is why the whole AI community is working on this kind of questions at the moment, how to establish trust in AI. This is the next part of, almost final part of my talk about AI and society. So as you understand now, there's a big movement towards making AI trustworthy and looking at the impacts of all these systems for society. Many groups have been doing study, research, and recommendations. So, for example, the Montreal Declaration for Responsible Development of AI, that was a bit 1 year ago, something like that. The European High-Level Expert Group from the European Commission published ethic guidelines for trustworthy AI, that was a few months ago. Japanese also, they produced these documents, Social Principles of Human-Centric AI. They more or less all talk about the same kind of things, huh? About trustworthy and responsible AI. The German industry has worked on the ethics of autonomous vehicles. It's a big question, and so they know what they are talking about, of course. Huh? The GAFAM, and now it's a bit more open, they launched a few years ago this partnership on AI to look at the social implications of AI. Now we are going to launch by the end of this year. When I say we, it's something that comes out of the G7 meeting last weekend in France, something like the IPCC of AI. So that will be called the Global Partnership on AI, where experts, etc., users, governments look at the implications of AI for society and make recommendations, such as the IPCC is doing for climate, etc. I said, some big challenges for the society: trust. I explain why, I think. The fact that you delegate your decisions to machine, it also has implications. So what should be the part of the machine, what should be the part of the human in this decision-making process? What happens in terms of employment, future of work? Big question on which we have to think, because we don't have to worry that much, because the current thinking on the future of work is that AI will not replace people, and that AI will help people, and we automate tasks, but not jobs. Some tasks which are not pleasant to do will be automated, but some others will be left for humans. But okay, we have to look again. Huh? The question of inequality and biases, especially when you work out of data, because data has biases, so you need to spend a lot of time looking at how you can cope with these big questions. Question of cybersecurity and privacy, as in many domains, but also in AI, and it's very sensible in AI because also it's able to propose decisions. So you have to look very closely at these aspects. And since a lot of these applications use data, the governance of data, how should I manage my big data sets, and how I'm going to use them for machine learning in particular is really a big subject. And so that looking at all this, we in the end will benefit from socially acceptable applications in very important subjects for society, such as I said, health, environment, mobility, whatever, industry, leisure. So This is what the European Commission, the level group, higher level expert group has published a few months ago, ethics guidelines for trustworthy AI. So, you know, they put a number of requirements for trustworthy AI. The first one, they call it human agency and oversight. It's the question of control by humans of what the AI systems are doing. So human oversight, human agency. Talking about technical robustness and safety. Of course, very important for critical domains such as autonomous cars, etc., such as process monitoring, industry supervision, etc. As I already said, the experts group talks about the necessity for governing the data, quality, integrity of data, how people should access that. Transparency, which is also an important factor for trust. If systems are opaque, then people will not understand how they function. So transparency, I'm showing my algorithm, I'm showing how it takes decisions, and then it will help me, it will help users in trusting the systems. And I already talked about explainability. Okay, obviously this question of diversity, non-discrimination, fairness. And then looking at environmental friendliness, democracy aspect, and accountability, which means that it's a question of responsibility around the processing by AI. Okay. About that one, huh? All these documents are available on the web. Huh? It's easy to find. Very interesting document done by the Ministry of Transport in Germany about the ethics of automated and connected driving. And another thing which is worth reading is a report done by like Kate Crawford and her colleagues from the AI Now Institute. They publish a report every year, well, only since 2017, about all the mistakes, problems encountered with AI systems or decision-making systems in the past. And it's very interesting to look at this in order to understand what are the potential consequences of these systems. So once again, I said you don't have to be afraid, but still it's worth taking precautions, looking at the possible impact, and that's very interesting. There are many, many things that you can read, but this one is also interesting. So I may have the time to talk in 5 minutes about our strategy in France. Yeah, no one tells me to stop, so I can continue. Okay. So we are in a movement in France. We have very good assets for AI. We have a good results. We are among the top in Europe in this domain. So yeah, 21% of European research labs in AI. In terms of industry, we have some big companies, as you know. Many of them are operating in Mexico, so in retail, in energy, in banking, insurance. We have innovative companies. We are now pushing a lot on the startups in France. We try to be a startup company also. And this was not the case 10 years ago, but there has been a lot of efforts in France. And now, yeah, we are really an attractive country for new business. And we also benefit from quality databases, especially in health, because of the social security database, which is something like more than 60 million users. We have a lot of data, and also we can connect this data to hospital data, etc. So, but also in other domains, we have good databases. So we are pushing for AI in France, and it has been thinking in the last 2 or 3 years. So 2 years ago, a bit more than 2 years ago, we developed the France AI strategy, which was presented to our president at that time. And 1.5 years ago, we had the AI for Humanity meeting in Paris, where President Macron listened to the report by our mathematician and deputy Cédric Villani, and made the decision to launch an AI plan, which is called AI for Humanity. And now we are really in this operation of this AI plan. So essentially what we are doing, so we have 1.5 billion euros for the 4 years of mandate, including more or less half of it is for our research and education. But we are also looking at data, because data is important for AI. So we want to open public data, and we also want industries to share data so that we can have good databases. but respecting privacy and respecting the GDPR, which is a European privacy law about data, which is purely European, but which is looked with interest by all the other countries. And as I said, we also announced that we will build an IPCC of AI, an independent expertise, looking at advising the world on what to do with AI. So in our strategy, we have three big elements. We have the talents element, which is research and training. So we want to attract the best AI researchers in France, and we want also to keep our best researchers. Dissemination, we want to spread AI in economy and in administration, and this is very interesting. In fact, we already started a few AI projects for the French administration. I don't know if many countries are doing that. Portugal also wants to do it for administration, for example. But okay, the main part is in the economy. And also we have this big place for ethics, because in Europe we are really considering that ethics attitude from AI is an important subject, as I said a few times. And we are ready, of course, to work with all the countries who share the same views about what AI behavior should be. And this is the case also for Europe. So we are not, in France, we are not alone in the world. We are a member of the European Union. And something like a few months ago, in December last year, there was the announcement of the European Coordinated Plan on AI. So the member states, the 27 member states, together with Norway and Switzerland, signed a cooperation. And now this is moving on. And so the whole of Europe is working together on developing AI applications, also considering the societal aspects of it. And it's a big plan in Europe for the future, with a lot of investment and with, as I said, all the countries involved, France and Germany being, I would say, the core part of that. So this was the positioning of France in all this. I want to stop here so that I don't know if we have time for questions, but yeah, I thank you for your attention, and I might answer to a few questions. I know.
I want to start in the way of AI. If I want to learn AI, when I have to start?
As soon as possible. You should start now. Start tomorrow. You can. I mean, here in the university, I think you have the facilities to learn, to get trained, and to develop and then you can do a PhD in AI if you want. I think is very welcome. Huh? I'm not saying that you can come to France too, but we are also Mexican students. Huh? But you have many opportunities to do that. We think that it has to be taught very early, because we think that computer science has to be taught very early. Starting in high schools and even before, maybe not all the complex notions, but now I think the earlier is the better. That's all I can say. You don't have to wait for I don't know what.
Do you think there is a lot that you can
a path to follow? I think here you are in a big university, so I hope, I don't know the programs, but maybe you can answer.
Yeah, we got several programs in mathematics, mathematics, computer science. We got two postgrads dedicated to studying computer science. One is postgrad in computer in science and engineering in computing, or the other is in mathematics, science as well. Both of them are.
So I think, and you have. I think some people think that it's only mathematics, but it's also computer science.
Yes.
Okay.
Yes.
I'm studying mathematics, but sometimes I don't know what is the relation between AI and mathematics.
Well, if you want to, the relation, this is from algorithms. So when you do algorithms, behind algorithms, there's a lot of mathematics. And with mathematics, you can look at the behavior of the algorithms. You can try to prove some results. You can try to dimension some of the features, the parameters of the algorithm. So there's a lot of mathematics involved. But also there's a lot of computer science because you have to program this in a machine, on a network with some big high-performance facilities even, etc. So you have to look at computer science aspects. Huh?
Why do you think another winter is coming?
I think that it could be rather soon if we don't pay attention to it. This is my message. So this is why a lot of people are looking at this question of trust, of ethics, of inequalities, etc., make decision making, because if we don't do that, there will be some problems. We're sure that there will be some problems. The other problem, by the way, is that if we go on announcing ambitious results and we don't get the results, that was the reason of the previous winters. Huh? So these two factors together, we are at risk. So at the moment, there's a lot of deployment. So maybe it's spring, maybe it's summer. I don't know. I don't know. But it could be quick if we don't pay attention to that. But I am not going to predict when. I'm not such an intelligent person.
I have three quick questions. The first one is regarding that point. You talk about some recommendations around ethics.
Yes.
Is there a country that's already working as formal regulation?
The formal regulations are not there yet. For the moment, it's only recommendation documents. There has been a statement by the European Commission, in fact, from 1 week ago, which is trying to do to the level of regulation, but it will take some time because there's too much uncertainty at the moment on all this. We are not really in a position of putting rules. So, in the world, as far as I know, there are no formal regulations.
Just to say, which the company sector of the country is more developed
In AI. So the big leaders in AI are USA and China. Yeah, okay?
sectors or companies?
Companies, as I said, the big leaders in AI are the GAFA and the BATX in China. So, big players, huh? But there are also smaller companies like Israel, which is very impressive. They have impressive results considering their size. Huh? And but Europe is also a nice place. I mean, France itself is something like between 5th and 9th in the world in terms of AI, depending on how you measure things. But Europe as a whole is also competing with US and China.
I have a question, and I noticed about the myths. I noticed that the distinction between weak and strong AI is a bit different from the original statement that shares in the Chinese room paper. And I wonder, about this, one of the probably the largest myth of computers, what is your position about whether computers can be conscious?
Do you have 5 hours? If I was able to define consciousness, then I would be very, very happy. But I think that it's the consciousness for computers and for machines and for people is something very, very different. But from this, once again, I would suggest that you talk with Jean-Gabriel, who is much better than myself on this subject.
Otra pregunta, other question? Yeah.
Do you think that at one point it will be unethical to upload an AI?
Unethical to, sorry?
It's that an AI has conscience of itself or something like that. It's unethical or moral to upload it.
You understand the question? Unplug the computer. We will always be. I think that we will always be able to unplug the machine because we are the ones who decide. That this is not what you say.
Dilo en español.
Que si en algún punto sería no ético apagar una computadora porque la inteligencia artificial es consciente de sí misma.
Okay, is it unethical to turn off the computer?
Sorry, I didn't understand.
Okay.
Yes, there are. There is a debate. There has been a debate about whether robots should have personality or not, should be officially recognized as beings. But so if they are recognized as beings, you know that in the world you have already 3 categories of things. You have human beings, so you cannot disconnect me. Not yet. You have all the machines, and animals have a special category. They are also recognized as some kind of beings, not to the level of humans, but not exactly as machines. So you have to be careful with what you do about animals. And so people have been debating whether robots should have this kind of same level as the animals. But there's no position yet. So, if this happens, then you will have also some limitations to what you can do with robots. But this is not the case for the moment.
¿Otra pregunta?
Yeah.
No.
Yes.
Gracias, Rose.
Okay. In your point of view, how many years do we need to wait to, for example, see regulation in which all countries that are developing AI, we can criticize or evaluate that technology using, for example, ethic regulations or, I don't know, maybe another topic that we are not considering today?
It will take a long time. If you look at the IPCC for climate, it took them something like 30 years before general agreement on what we should do for our planet. And so for the moment, we are only starting to mobilize the community about the questions with AI. So it will take many years. I'm not saying how long, but there's a big, there's consciousness about things that we should do. But yes, since it's a global process with a lot of countries, people, interest involved, it will take a long time.
¿No otra pregunta? Sí.
I have a question. For example, in the case of automatic cars, there's a lot of things related to that. For example, you have a lot of physics and mathematics, statistics, computer science.
Yes.
So my question is, what's better, like to specialize in something specific, or know like a little about all these things?
If you want to work so the question is, if you want to work on autonomous cars, do you have to specialize, or do you have to all learn everything about mathematics, physics, computer science, traffic regulation, whatever? Okay. Well, autonomous cars are not being built by one person. They are built by groups of thousands of people. Thousands of people are contributing. So there are many specialties. So I think you can specialize, and you will find some good job. Okay, you will find some good job. But as a person, I also suggest that you have a broad view of all these aspects in order to understand the big challenges. But it's not a problem to specialize in one of these disciplines. You will find some opportunities.
Hi, so I'm a professor here in this institute, and I know that we have I'm a professor in this institute, and I know we have very tight collaboration, for example, with the CNRS, because we have a meeting that we know about in Guatemala. And do you know, or is the INRIA capable of having such collaborations? Are they interested in establishing that sort of connection with Mexico, specifically with mathematicians or the people like us who are working in these fields?
We have, if I talk about INRIA itself, we have something like, we collaborate with a lot of countries, with a lot of universities worldwide. So yes, this is obviously open. We always want to work with the best, wherever they are. Yeah, okay, you can explain that. Well, yeah, we have what we call associated teams, which means an INRIA team is associated with another team for 3 years, and then they travel, they see each other, they work together on some project. This is the way we are doing it. Thank you, Monique.
And the last question?
Thank you.
I
just.
wait, just keep, well, raise the hands beautiful, and then the last one is yours. Okay, yes, you first.
What do you think is going to be the next big thing in AI? For
So the question is, what will be the next big thing in AI? I think of two, personally. One, as I said in my speech, is trust. That's the thing on the subject on which everyone wants to work. And so if we get to some trust level, be it deterministic or probabilistic, we have made a big step forward. So that's one point. But my other point is that at the moment, as I've said, we are building weak AI, so systems which are able to do one thing very well, but just one. But we humans, we do a lot of things at the same time. And our systems are not able to do that. And in order to, I think I would be very surprised if you put all the data of the world in a box and then you put a big algorithm to learn everything and then you get the answer. No, it won't work like this. And so we will have to combine different AI artificial agents to provide more complex behaviors. And so I think that the next big thing should be, but I'm not saying that it will happen, should be distributed AI, collaborating agents in order to solve more complex problems. Sorry, I didn't hear. Yeah, okay, yes, we can say it like this, if you want.
Yes.
I'm just curious, in the Casablanca example, you show an image with the legend, an attractive French woman, something. Did you train with attractive and unattractive people, or how did you get?
Sorry,
Did you train it with
no. What example?
the
Ah, okay. It's not attractive person ones? You have to, yeah. But this has probably been in the training set, yes. The system doesn't decide by the system has not invented the notion of attractiveness. So it has been put had been put inside by some trainer, yes. Because this is supervised learning, so I didn't give any technical presentation of AI. But this is more or less, all of this is supervised learning. When I say that you train system, it's because you have also the answer given by a human operator, which gives the solution. This is how you learn things. Huh? So then if all the concepts have been put by humans.
Yeah.
Thank you very much for your attention.
Well, thank you.